Hello guys and welcome to BNU1501 first class. Today we are going to cover chapter 1 and chapter 2 of our class using the available questions on your screen. So on chapter 1 we will cover sections where they will ask you to round off a number. They will give you a certain number to round off. So when you are rounding off a number, there are two things that we need to take note of. We need to check what they will say about the decimal digits. How many decimal digits do they want us to round off to? Okay, so for example, if they give us on question 1, they said 22,49258. Then they say round off to 3 decimal digits. So if they say to 3 decimal digits, the first rule that you need to do is to count 3 numbers after the comma. 3 numbers after the comma, that means 1, 2, and 3. Once you have counted 3 numbers after the comma, that means that's the number that they want. Then you look for the number that follows, which is 5. Then you apply a rule which says if the number is between 0 to 4, you don't round off anything. But if the number is from 5 to 9, you round off upwards, like you add 1 on the last number. Hence, we can see that our number is between 5 to 9. So our rounding off final answer will be 22.49. Then we add 1 on the 2, then it becomes 3. Because we can see that the following number is 5, which is between 5 and 9. That will be how to round off a number such as this to 3 decimal digits. Okay, let's apply the same concept again. On question 2, they asked us the same thing, to say round off round off to 1 decimal digit. So if they say round off to 1 decimal digit, we are going to apply the same concept. Here we have 250,192 to what? 1 decimal digit. So we said for 1 decimal digit, we count 1 after the comma. There's only one number that we need after the comma. Then we look at the following number. Is it between 0? Is it between 0 to 4 or 5 to 9? We can see that is between 5 to 9. So we add 1 on the number that we want. So our final answer will be 215.2. Or they say round off to 1 decimal digit. So this will be our final answer. So whenever they talk about rounding off figures, you need to check if the number is between 0 to 4 or 5 to 9. Say for example, they said round off a number to 2 decimal digits. Like the same number, let's say they say 250.192 to 2 decimal digits. If they say to 2 decimal digits, we will need to count 2 numbers after the comma, which is 1, 2. Then we look at the number that comes after, which is 2. And we know that our rule says is 0 to 4 or 5 to 9. So we can see that 2 is between 0 to 4. So we don't round off anything. So our final answer will be 250.19. We leave it like that. So you need to take note of this when you're rounding off figures. So that is what you need to master. That is our first part of the lesson today. So when you're rounding off figures, that's what you apply. Okay, after that, we move on to the next part of the questions we're covering today. On question number 3, they said round off 3,496 to the nearest integer. An integer is a whole number. An integer is a whole number. It's a number without a comma. An integer is a number without a comma. So in other words, we need to get rid of the comma. So what do we do to get rid of the comma? We will look at the number that comes after the comma and apply the concept that we said is it between 0 to 4 or 5 to 9. We can see that it's between 0 to 4. So if it's between 0 to 4, that means you don't round off anything. However, we can see that there's 4, 9, 5, 4, 9, and 6. So by looking at these numbers, we can see that rounding off a number such as 49, right, is below what? It's below 4. So our final answer will be 3. That will be our integer. Because 4 is between 0 and 4. Having said that, our next part that we are going to cover today is when they give you a scenario in which they tell you a statement which you need to express in mathematical form. So they will tell you a sentence which they want you to write in mathematical form. How do you do that? In mathematics, we have what we call variables. Variables. A variable is an unknown number, right? So a variable is represented by any symbol or a sign that represents an unknown number. So it's any sign or symbol or a letter that symbolizes an unknown number. Examples of variables can be x, can be y, can be z, can be pi, can be r, can be p, can be q, any symbol, as long as can be infinity, any symbol or letter that is used to represent an unknown number, that's a variable. Okay, so having said that, where we want to now formulate a mathematical expression given the statements above. On question number 4, they said if a certain number x is multiplied by 8, a certain number x. So we don't know how much is the value of x, what is the actual number, but we know that that number is represented by x. So they are saying a certain number x, right, is multiplied by 8. Is multiplied by 8. It will be equal to 3 less than twice the same number. 3 less than twice the same number. That means twice the same number, which is the number which is x. So twice that number is 2x. Is 2x. So if they say twice the same number is what? X. And if it's twice, that's 2x. Less 3. So now we need to formulate a mathematical expression which interprets this statement. Hence, we are going to say 8 times x, it will give us 8x. It will give us 8x is equal to 2x minus 3. So that will be our expression of the given question. Then we move on to the next question, which is question number 5. On question number 5, we're still formulating a mathematical expression given a statement that we will be dealing with. On question 5, they said, I have 12 coins. I have 12 coins. X of them are 5 coins, and the rest are 1 rand coins. So we have 12 coins, and on those 12 coins, there are 1 rand coins and 5 rand coins. As an expression in terms of x for the number of 1 rand coins I have left is. So they've already indicated to me that I have got 12 coins. So out of 12 coins, if I take out X coins, I'll be left with 1 Rand coins, because X coins are representing 5 Rand coins. So if they are representing 5 Rand coins, it means out of all the total of 12 coins, which includes 1 Rand coins and 5 Rand coins, X of them represents 5 Rand coins. So if I take out X coins, I'll be left with only 1 Rand coins. So we need to formulate an expression that explains how many coins are left from the 12 after we took out the 5 Rand coins to be left with only 1 Rand coins. So if in total we have 12 Rand coins, we have 12 coins, and X of them are 5 Rand coins. So if we subtract X of them, then we will know that everything that is remaining is 1 Rand coins. But we don't know the exact number of 1 Rand coins we have in the 12 coins we have. But we know that if we say 12 total coins that we have and we subtract X coins which are representing 5 Rand, we will have what? Our 1 Rand coins that will be left. So this is the expression that we are looking for. We have total 12 Rand coins, we subtract X of them, we'll be left with 1 Rand coins in total. Okay, then the following question also is indicating the expressions. Question number 6. They will give you an expression. So when you're in the exam, you need to remember that these statements, we don't have a standard formula to which we can say you must follow this formula. All you need is to read the statement and make sense out of the statement, so that once you understand the statement, it becomes very unique for you, and you then interpret it using figures. You have to interpret it the way you understand it in figures. Say, for example, on question number 6, they said the correct expression for a number, we don't know what that number is, so we need to represent that number with a variable. So they said an expression for a number which is 7 times as big as the number obtained after P has been increased by 2 is. So they said the correct expression for a number which is 3 times as big as, which is 7 times as big as the number obtained after P has been increased by 2. So we can see that now we have a P value, which is a number we don't know, and that P, we are going to increase it by 2. Then when we increase P by 2, and that number that we are looking for is 7 times as P plus 2. So in other words, we are saying P plus 2, right? They said after P has been increased by 2. So if we increase P by 2, then we come back here and say, what are they saying in terms of 7 times as big as the number? So we are saying the number that we are looking for is 7 times as big as this number here. So what do? We now then say this number multiplied by 7. Because we are told that an expression for a number which we don't know yet, which is 7 times as big as the number obtained after P has been increased by 2. So if we increase P by 2, then we multiply that number by 7 to get that number that we are looking for. So our answer will be 7P plus 2. Okay, having said that, we move on to question number 7, which is also an expression that we need to formulate. Now, on question number 7, we are now moving on to another section of the topic that we need to cover, which covers the ratio. When you are dealing with a ratio, the ratio is a measure in which how much each individual or each part who is going to get from the total amount that we have. It might be a total amount of money, it might be a total amount of profits, it might be a total amount of fruits, whatever that we are going to share. amongst us who is going to get what. That's a ratio. So when you come across a ratio, like on the question number 7 that we have, an inheritance of 72,000 is shared between 3 siblings, A, B, and C, in the ratio of 2:1:5 respectively. Sibling C will inherit what? So what we need to establish when we're dealing with a ratio is we have sibling A, B, and C. So they share in the ratio of 2:1:5. Right? That means this is the ratio that they're sharing one. So when you're dealing with the ratio, first step you need to do is to add all the ratios that you have. So you are going to say 2 plus 1 plus 5, which gives you what? 5 plus 1, that's 6 plus 2, that's 8. So it will give you a total of 8. Then you will come back and say, how much does C have? Right? You can see that C is getting 5 out of 8. So what you do is you want to know how much in terms of rands that sibling C is going to get. So C is going to get 5 out of 8 of 72,000 rand. Which when you calculate that, you obtain 72,000 times 5 over 8, which you will get 45,000. So the other sibling C will get 45,000. So whenever you're dealing with a ratio, that's what you need to remember. You add the ratio first, all of it, then it will give you a total. Then you say the ratio of an individual that you want divided by the total amount of ratio times the figure that you need to apportion amongst the participants that you are sharing on. Okay, so having said that, that's the part that you need to remember whenever you're dealing with ratios. Ratios, you add the ratios, and then the total of ratios you divide it by the amount that each individual is sharing. Another example can be if you want to know how much B is going to get, So we are going to say 1 over 8 times 72,000. So we need to know how much B is going to get. Then we will know that B will get 9,000. So those are the ratios. Okay. So after the ratios, we need to talk about the next question, which is covering some part of section chapter 2 of our studies. On question 8, we can see that now we are dealing with a ratio, but our ratio is dependent on certain variables. They said a baker bakes a cake using 200 grams of flour. So they use 200 grams of flour and they use 30 grams of sugar, and they use also 100 grams of butter. So we have a ratio in which a baker uses to bake a cake. So they said we need the expression that describes the amount of flour needed in kgs to bake X cakes. So we need to know how much amount of flour, and we can see that amount of flour is 200 grams per cake. But it's given in grams, not in kgs. Their answer, they need it in kgs. So what you need to do is we need to know that for every 1,000 grams is equal to 1 kg. So for every 1,000 grams is equal to 1 kg. So now, if we have 200 grams, how much kgs do we have? So you will say 200 divided by 1,000 is equal to 0.2 kgs. So if we convert 200 grams into kgs, it will give us 0.2 kgs, which then states that if we can have 0.2 kg per cake, how many cakes do you want to bake to know how much amount of flour we're going to need? We don't know how many cakes we're going to make, but we are told that those cakes are x, which is a known number, which is a variable. So we are going to say 0.2 x kgs. Because we are of the opinion that it's 0.2 times x, which is also be written as 0.2 x kgs of flour we need to bake x cakes. So basically, we just need to interpret the question, but we needed to add an additional information in terms of knowing how to convert from grams to kgs. Okay. Now, having said that, we now need to move on to the next part, which is also simplifying an expression that will be given. Okay, on question number 9, we are given an expression that we need to deal with. If in the exam you are given such a question, usually most students, they'll just punch in their calculators to get the answer. However, I need to show you how we work through this step by step. So you are given 5 over 6 minus 3 over 4 times 6 over 5. So this is a fraction. So when you're dealing with a fraction, you need to use what you call body mass. So body mass states that we must deal with brackets first and then division, multiplication, addition, and subtraction. But here we can see that we have got multiplication. So we need to deal with multiplication. When you're multiplying fractions, it's very simple. You just multiply 3 by 6, which is 18, and then 4 by 5, which is 20. Then you bring down 5 over 6 minus 18. Then you look for a lowest common multiple. A lowest common multiple. We're going to cover that in detail just now. Then you look for a common denominator between 6 and 20. The number that 6 can get into that number without leaving a remainder, and 20 as well, which is 60. Then we will say 6 into 60, how many times? It's 10. Then 10 times 5. Minus 20 into 60 is 3. Multiplied by 18. So this will then lead to 10 times 5, which is 50, minus 3 times 18, which is 54, divided by 60. So if we work out this, it's going to be negative 4 over 60, or 4 into 4 gets once, into 60 gets 15 times. So our answer will be minus 1 over 15. That will be our answer. So you need to remember that. So basically, that's part of the lesson that we need to cover today when you're dealing with a fraction. We're gonna deal with this in further detail in our next section. Okay. Our next section that we need to cover is when you are dealing with exponents and roots. When you are dealing with the roots, such as question number 10, which they usually like to ask in the exam, they gave you so I need to give you a background before we approach that. When we talk about a square root, we are looking for a number that we can multiply twice and give us that number. For example, if we want a square root of 4, if we want a square root of 4, we need a number that if we multiply that number by twice by itself, it must give us 4. We can arrive to the fact that 2 multiplied by 2 will give us 4. So square root of 4 is equal to 2. Then we can say, okay, what about if we are looking for a square root of 9? A square root of 9 will be 3 times 3, because 3 times 3 will give us 9. So if we say 3 to the power 2, what will it give us? It will give us 9. So we are now saying a square root is when we are coming from a higher number to a lower number. A power root is when you are coming from a smaller number to a bigger number. So what are we saying about this? Let me reiterate my point. In other words, we are saying if we are looking for a square root of 4, if you are looking for a square root of 4, if you are looking for a square root of 4, it's as good as saying 4 times 1 half or 1 over 2, which will give us what? 2. But if you want to go back to 4, we will then say 2 to the power of 2, it will give us 4. How 4? Because 2 to the power 2 is as good as 2 times 2, which is 4. So what I want to arrive at is that if ever you are dealing with square roots, you need to multiply by half if it's a square root. If it's a cube root, for example, if we say 125, cube root of 125 is as good as saying 125 to the power 1 over 3. If you say cube root of 16 is as good as saying 16 times 1 over 3. If we say fourth root, right, of 100 is as good as saying 100 times 100 to the power 1 over 4. That's basically the idea. So, but you never deal with a fourth root and cube root. Usually, it will only be square root at this level. So now, having said that, we now need to look at the question that we are given. They said a square root of 36, x to the power 16 and y to the power 4. So like what we said, we need a square root of 36. So we are going to say 36 times half. Then x. Now we need to explain another point where we need a square root of an exponent. A square root of an exponent is exponent times half. A square root of an exponent is exponent times half, which then arrives at 36 times half. It will give you with a square root of 36. which will be 6. So if you say 36 times half, it will give you 6. Then x to the power 16 times half, that will be 8. Then y, 4 times half, that will be 2. So what you need to remember is x to the power 16, x to the power 16, 16 is an exponent, and x is a base. So we are saying, as long as you are looking for a square root of an exponent, you multiply by that exponent by half. You multiply an exponent by half to get the answer that you are looking for. So that's very important. You must remember that. Having said that, we can move on to a part where we talk about revenue, profits, and costs. In BNU, usually they will throw in a question where they want to ask you about profit or revenue or cost, whichever way. But you can, it's more like accounting principles that you'll be applying in a mathematical world. So, like question number 11, they said, Mr. Kumalo sells his car for 750,000. The total commission is 7.2% of the selling price, of which the broker receives 2/3 and the salesperson receives the rest. The broker receives what? So here it's a matter of how much share does one have. Now we are also applying what? Ratios, which we can also use. So what we need to take note of is the cost of the car, the selling price of the car is 750,000. So if they say they are selling the car for 750,000, then they get a commission of 7.2%, right? But out of this commission, how much is the commission that they're going to get from 750,000? So they'll get a commission of 54,000 rand. This is the commission that they're getting in full after selling the car. But they are saying now that of which the broker receives 2/3 and the salesman gets the rest. The broker receives how many? So the broker is only getting 2/3. A 2/3 is multiplied by 2/3. That's a 2/3. Which now then we multiply that, then it will give us 36,000. So the broker will get 36,000 off the commission that they've earned. So what you need to do is to look for the 7%, 7.2%, then you calculate 2/3 of that 7.2% to know how much the broker will take home. Okay. Then you will be warm and dry. So it depends with the question that is given. All you need to know is when you're dealing with a percentage, right? Whenever you're dealing with a percentage, you need to remember that any percentage can also be written as 7.2% is equal to 7.2 over 100. So if you're using a calculator, it's simple. If you're not using a calculator, you can just say 7.2 over 100 as a percentage. So in other words, you will first look for the percentage of 750,000 that is being paid as a commission, and then after that, you multiply how much they are getting. So when you're dealing with a percentage, this is also part of chapter 2 of our study guide that we need to look at in terms of percentages. Now, having said that, we will move on to the next segment of our chapter 2, which is simplification of expressions. When you are simplifying expressions, there are two most important things you need to remember. Either the expression is being multiplied or divided, or it will be adding or subtracting. So for now, we are going to deal with the one that is adding and subtracting an expression. So when I simplifying an expression which is added or subtracting, you know that you only combine like terms. If they are not similar, you don't combine them. In other words, you are saying boys to boys, girls to girls. They will never mix. So looking into that, on question number 12, they gave us an expression which says 4a to the power 2 minus 6a b plus 2b squared minus 3ba minus 2b squared. So first and foremost, the first step you need to take is to remove brackets. So when you're removing brackets, you just, everything that is not in the brackets, you write them as they are. You write it as it is. Then when you are removing brackets, you multiply the number that is outside with everything in the brackets. For example, here you say 3 times BA, it will be 3AB. Here I'm just writing in terms of alphabetical order because A comes before B, so I'm just rewriting it in alphabetical order, but it looks the same thing. Then we will say minus 3 times minus 2, it will give us a positive 6b squared. Then we have removed the brackets. Then step 2, you need to group like terms. So when you're grouping like terms, you're now looking for similar items and group them together. So here we have 4a squared. Do we have any that is similar with 4a squared? We don't have. Then we move on to minus 6ab. Do we have any number that has got ab? Yes, we have 3ab minus ab. Then we move on to the next one, which is plus 2b squared plus 6b squared. They are similar. Then after that, the last step that we can take is to calculate. So when you are calculating, 4 is going to be left alone. 6a minus 6ab minus 3ab, it will give us minus 9ab. Then plus 2b squared plus 6b squared, it will give us plus 8b squared. Then that is all we can do by simplifying. So when you are simplifying, we are just saying rewrite this expression. We are saying rewrite this expression to its simplest form, which is this. That means it still means the same thing, but in a simplified version. So you need to follow these steps one by one. First step, remove the brackets by multiplying by 3. The second step, you group like terms. Those are similar. Then lastly, you calculate. Having done that, that is the very important part. And this question, they like to bring it in the exam. So you need to master it. You need to remember all these 3 steps. You need to remember all these 3 steps. Right? After that, we also want to look for another expression that is given that we need to deal with. On question number 13, we are also given an expression. The expression goes as 2a open bracket b squared minus 1 close bracket minus 3b open bracket ab minus 2. Now, this expression is similar with the one that we did. Now we need to deal with it. So we said the first step, you remove the brackets by multiplying any number that is out of the bracket times any number that is in the bracket. So what you're going to do, we're going to say multiply 2a by everything in the brackets and 3b by everything in the bracket, right? So we're going to say 2a times b squared. We're going to have 2ab squared minus 2a times 1 is going to be 2a minus, this is minus here, 3b times ab, we're going to get 3ab squared, where there's b and b becomes squared. Then 3b minus 3b times minus 2, it will give us plus 6b. When you are multiplying negative numbers, they will give us a positive answer. Okay, having said that, that's the first step. The second step, we agree that we're going to group like terms. And the like terms on this scenario is 2ab squared, right, minus 3ab squared, then minus 2a plus 6b. Then after that, we will then say 2ab squared minus 3ab squared will get minus ab squared minus 2a plus 6b. Then we are done. We cannot go any further than this. Reason being, this is not similar with this, not similar with this. So we cannot move any further than that. So this will be our final answer. Okay, some might ask, why did I say ab squared here instead of 2 minus 1 is minus 1? Yes, it's minus 1 is correct. But in mathematics, this minus 1, we don't usually write it. 2b minus 1 ab squared. In mathematics, we don't write it. We just leave it like that. So we need to remember, when they give you an expression, these 3 steps, they are very, very important. These 3 steps are very, very important for you to go through.